Hey everyone, thanks for coming. I'm going to talk today a little bit about rethinking production monitoring. Before I get started, who the hell am I? My name's James Smith. You probably tell by my accent I'm not from around here. I'm from London originally, but moved to San Francisco about 6 years ago. And my background is I've been working as a software engineer or a CTO or in the realms of the software space for around 10 years. And during those 10 years, I've been focusing a lot on production monitoring and what the health of your application looks like to your customers. So back in London, I used to work in finance. I worked for a big finance company. And in that role, I was rolling out software, trading platform software that was processing billions of dollars of transactions a day as a graduate, which was absolutely terrifying. And if that software crashes or breaks or there's downtime, billions of dollars of transactions disappeared. More recently, I moved out to the Bay Area to join a company called HeyZap, where I was the first employee and CTO. Saw that whole situation from a different perspective. So running a startup or being the first employee and CTO at a startup meant that the buck stopped at me when it came to production monitoring. If something was broken, it was on my head. I had to solve it or make sure that systems are in place such that everything was working or our customers were happy. And now, in my role as co-founder and CEO at Bugsnag, I help every other team in the world, hopefully, have awesome production monitoring. So what's Bugsnag? Bugsnag is a platform for detecting and diagnosing software problems. So we're giving engineering teams the tools and workflow that they need to spend more time building software and less time fixing. And we do that by letting you take a proactive approach to software quality and software monitoring. And I'll dive into that a little bit later, not in terms of Bugsnag, but in terms of how you can take that proactive approach in your own companies. So what am I going to talk about today? I'm going to talk about how production monitoring is broken in most software companies, or in most companies that have software in general. I'm going to talk a little bit about what better production monitoring looks like and some philosophies around that. And then finally, I'm going to talk about how you can take these philosophies and learnings and actually implement them in your own teams and in your own company. And the idea here is that we want to take this kind of cowboy attitude from YOLO to confidence over here. This is a common theme that's going to come up throughout this talk, and I'm sure you guys have seen this in your own companies and your own teams as well. So before we dive into this, what do I mean by production monitoring? So typically monitoring covers three main areas in production. So this is after you've shipped code out to your customers. So area number one, stability. Is my app, or is my software, is my product working when we give it out to our customers? Is it crashing? Are they seeing the app close every 5 minutes? Or if you're a website, you're seeing 500 errors show up all the time. That's area number one. Area number two is performance. And performance is more about, is this fast? Is this a good experience for my customers in terms of the speed of a page load or the scroll speed of a list of items in a mobile application? And the third part of production monitoring is availability. So if your app is not responding, it's not available, your API is down, you're literally not going to, your customers aren't going to be able to use the app at all or your product at all. So really what that means is those three areas kind of turn into one thing. Are we delivering an awesome experience to our customers? Because if it's not available or it's slow or it's crashing, your customers are going to get annoyed, and that's on you. So hopefully this will be obvious, but I'm going to go over it anyway. Why does this matter? Why do we care about stability, performance, and availability? So it's never, ever been easier to start a company, especially in software. You can set up HR, you can set up payroll, you can get servers in the cloud for super cheap, you can learn how to code yourself, you can build a company super quickly, super easily these days. So thousands of amazing new sites and products and apps are being built every month. So this is great news for the consumer, for your customer, because they now have a choice. If your app is broken, slow, or unavailable, they're not going to be happy. So what happens when you have unhappy customers? Well, your app will live or die based on its quality. 84%, this is a stat from a recent study that came out last year, 84% of your customers will abandon your app after seeing 2 crashes. So taking that a bit more broader than crashes, if you're not available twice, or if you've got performance problems that's causing people to leave your software, 84% of your customers will leave after seeing 2 production problems. And what does that mean? That means you've got abandoned purchases, you've got customer churn, you've got people writing bad 1-star reviews on the App Store. It's not a great situation to be if you have unhappy customers. But there's another part to this puzzle as well. Not just abandonment. You're generating technical debt unless you're monitoring what's going wrong in production on your software. So if you don't care about production quality, this is something that adds up over time. 1 bug becomes 10 bugs, become 100 bugs. It's really, really hard to recover from technical debt. So having an approach that is iterative and having awareness on production monitoring is crucial. And it can drastically cut down the amount of time you're spending finding and fixing bugs. And this is another stat from a recent study. 49% of all engineering time is spent finding and fixing bugs. And it's really interesting. You should try this in your teams when you go back. Everyone's like, no way, we're shipping features all the time. This is not a real stat. Go and measure it or go and kind of do a survey in your teams. It's actually horrifying to measure actually how much you're spending finding and fixing production problems or bugs. So now we know this is important. How can we work out what's broken about production monitoring? How can we work out what we're doing wrong as companies or software teams? What are the sins that I call of production monitoring? So, sin number 1, and this is the scariest of them all because I see it all the time. And maybe you guys see it as well, but pretending nothing is wrong. So, a lot of software teams think that shipping to production is the end of the process. And if you actually look at the waterfall model, the classic old school waterfall model, it would stop. It would go down the stack and it would be like, production, great work everyone, pat on the back. That's not the case anymore. If you believe that nothing is wrong in production, then you cannot have effective production monitoring and you're going to have unhappy customers. These are some kind of real quotes or quotes that I've adjusted slightly, but the sentiment is 100% true here. I've written tests. Surely there's no problems in production. It blows me away every time I hear this. This problem of nothing is wrong often stems from an over-reliance on unit tests, integration tests, and continuous integration. You can be the best person at writing tests in the entire world, you're going to miss something, and you need to be okay with that. So testing is just part of the process. If you are a mobile developer or a web developer, you'll know this already. If you go and look at a mobile team, and they've got a room somewhere that's got racks of Android devices in there, and they're still missing production problems. If you're a web developer, you've got someone who's using IE6 in the wild, or you're relying on some kind of new JavaScript, ECMAScript 6 thing that is not available on one particular browser. You need to test all of these environments. You're going to miss stuff. It's inevitable. So what else? The next sin, give me a second here, waiting for customers to complain. This happens all the time as well. This is almost a historical thing as well. So in the past, in this waterfall model, you would have a QA team and you would have a customer support team, and it was their job to see what's happening in production, which makes no sense to me because your engineering team is the team making the bugs. They should know about the bugs most of the time. So if you've got a customer complaining to your customer support team, that eventually, hopefully, trickles down into your engineering team. You're going to know a little bit about what's going on. But the horrifying thing is that most customers will not complain when they see a problem. They will just abandon your application. They'll abandon your software. So if you're relying on customer support to tell you what's wrong, you're probably missing 95% of the problems out there. That's a big sin. It's horrifying. I'm seeing it in a lot of companies as well. Some more kind of, this is a real quote again from I think this was from a CEO at a company who kind of was doing this a little bit. No, everything's fine. We're not seeing any complaints. But interestingly, it's now a little bit easier to get these complaints in the form of reviews. If you're a mobile app developer, you've got the App Store or the Google Play Store where there's comments and reviews and ratings in there. It's bridging the gap a little bit, but it's still a big sin to just rely on customer feedback. The third big problem, the third major sin in my books, is a lack of visibility. And this stems from an over-reliance on log files and what I like to call black hole systems. So you'll write a log statement, or you'll put in some instrumentation into your app, goes into a log file. You think, great, we have production monitoring now. But where is that data surfaced? Do all your engineers have access to this logging data? Is it easy to look at? Is it something that people are looking at every single day? I'm betting this is true from almost everyone here. We're like, yeah, we've got log files. Nobody cares. Nobody looks at them. And what they'll be used for is when a customer complains, looking at that timestamp and confirming it and helping reproduce. But if you're just relying on log files, the black hole of visibility, that's a big sin. You're going to miss things. You're going to miss a lot of things. The kind of second part of this is if you're relying on log statements, you're going to forget to put a log statement in somewhere important. So something will go wrong, and don't think that because there's nothing in the log files, nothing went wrong. You might forget to put a log statement in. And the final big sin is a lack of ownership. So let's say you've got a great production monitoring system in place, and it's tracking all the information you want to hear. Who cares about this? Whose job is it to actually look at this and give a shit about this? So you need to have a clear story. I'll go into this a lot in a minute. You need to have a clear story about who is responsible for dealing with production problems. And there's some other kind of horrendous quotes here. And I guarantee everybody in this room has had these pressures on their minds. You've got to ship a feature. You think this is not my side of the company. This is not my problem. It's common. I get it. It's reasonable. But it's a big sin because it means that even if you've got monitoring in place, you're going to miss things. You're not going to fix the big problems that your customers are being affected by. So now we've got that kind of understanding of what I think, at least, are the big sins of production monitoring. How can we do better? So what I'd like to do is I'd like to break down my 7 kind of commandments or core principles of production monitoring. And in theory, these can be applied within any software team, and it will help you turn a production issue into a solved problem. In those 3 categories as well, not just in errors and crashes and bugs, but in availability and in performance as well. I kind of noticed actually after I made this list up here, if you guys are familiar with the kind of the stages of grief, where it goes, whatever to acceptance at the end, bargaining and acceptance. I kind of try to avoid that, but maybe you can call it the 7 stages of production monitoring grief. So let me rewind a little bit here. Okay, there we go. Step number 1. Accept that you are going to miss things and accept that problems will happen in production. It's okay to miss problems. Continuous integration and testing is great. It's not going to find everything. Just be okay with bugs getting into production. Once you accept that bugs are going to slip through into production, you're in a great position to iterate faster and to continuously improve your product based on the problems that your customers are seeing for real in production. This also means you can focus on the problems that actually happen rather than the theoretical problems. Second principle, automate. So we already said earlier, you're wasting 49% of your engineering time finding and fixing bugs. The more we can do towards automation, the better. It's unacceptable spending that amount of time on finding and fixing bugs because you want to be working on delivering new features and new value to your customers. So use or build tools yourself which automatically detect problem situations for you. So rather than I'll go into this a lot more later on, but rather than having try-catch statements or logging statements all over your code or instrumenting manually, try and be clever about it. Try and find the areas where you can capture this data in a single place. And I'll go into what that means a bit later on. So, third key principle, aggregate. Don't just have a stream of events coming through. In error monitoring, you could say, oh, here's a stream of exceptions, let's write them out to a log file. In performance, you could say, this particular code was slow, this particular code was slow, this particular code was slow. In availability, you could say, this downtime incident happened, this downtime incident happened, this downtime incident happened. You can get smarter about this. You can take those streams of data and you can aggregate them based on some heuristic. I'll go into some heuristics later on, but here's some questions that you can ask to work out what heuristic makes sense. So like in a availability or in a quality and crash scenario, you can ask a question, do all of these crashes come from the same line of code? Do they all originate from the same line of code? Or in a performance land, you could say, hey, are we seeing slow performance only when, like if you're an Instagram app or something like that, only when more than 50 photos are loaded in the stream at once? So you can ask these questions, and you can use those questions to develop heuristics, which will say, aha, this stream of data can actually be collapsed down to this happened, and these happened, each of these events happened n times. By grouping, you can then measure how many times each problem happened. So you can then understand which issue is happening multiple times, and you can understand things like how many customers were impacted by each issue. It also allows you to cut down, I'll go into this later again, but the amount of data that you're generating. I kind of hinted on this lack of visibility earlier as a sin. A lot of people end up having log files or streams of events, and you end up with just data. And data is all well and good, but what you need is clarity. You need answers. So if you can aggregate this stream of crap into something that is actionable and meaningful, then you can do something about it. Fourth principle, notify. So alert your dev team where they already communicate. I'll dive into that in a second as well. But collecting and aggregating issues is great, but it's not enough. When the shit hits the fan, we want to know immediately, and we want to be proactive about things. So if you've implemented sensible aggregation, as we were just talking about, you can actually do something really clever. You can be smart about alerting. So you can say, rather than having a stream of data coming in to my email or chat rooms or whatever you're using to communicate, you can say, only alert my teams when this problem goes above a particular threshold. And you can alert only on groups of problems and groups of production issues rather than individual streams of data. And that will mean that you're not overwhelmed. If you have everything coming into your email or your chat room, you'll get blindness to this kind of stuff. I've got an interesting anecdote about this as well. And I'm going to look around and see how many people are like, oh, we do that. In one of our customers' companies, before they used Bugsnag, they used something in Ruby land called exception notifier gem. And what this does is, every time an exception happens, it will email one or more people on your team, which is great in development, or it's great when you've got 10 customers. If you take this out to production and suddenly 10,000, a million people see the same bug, that's going to come flying into your inbox. And we actually had a customer I talked to who assessed severity of a problem by getting an email from Gmail saying that they've hit a rate limit of the number of emails that they have coming in. I saw a few people there who were like, oh, okay, that's bad. Yeah, it's better than nothing, but it's still really scary to me. So notify and use that aggregation we were talking about earlier to cut down that noise and make it meaningful. Don't archive these. Don't put them in a filter. So, fifth principle, prioritize. And this sounds obvious, but we've just been building this set of tools up to allow us to do this. So, the dirty secret of software development is that you cannot fix every bug. I'm going to say that again because I want to see if people agree or if there are people out there who are fixing every single thing that comes in. The dirty secret of software development is you cannot fix every bug. A few nods back there. So there's a big shift from taking things from development to production. If you're lucky enough to succeed and have a huge app out there, you're going to have to make sacrifices. You're going to have to make decisions about what you want to fix first. So how can you do that? You've got a busy team. You've got finite time. You need to make sure you're focusing on the most harmful problems first. So we've already done the step earlier of aggregating these issues together. By aggregating on some heuristic, one of the heuristics we were talking about earlier, and I'll go into that, some actionable ones later on, you have some metrics now. You can say this one bug affected 10,000 customers. You can now prioritize. Which one should I work on? Let's focus on the ones that are affecting the most customers. Same with performance. You can say this performance, the page loads took longer than 200 milliseconds in this controller or in this piece of code this many times. Let's go and check it out. So you've prioritized. You now know what you're doing. You've detected things. You've prioritized them. Let's make them actionable. So you need to be able to diagnose problems. It's a waste of time just saying, here's all my problems. What are we going to do? YOLO, here we go. Just leave it out here. You need to be able to do something about it. You need to take it to actionability. So automatically detecting things is great, but in order to fix a problem, you need to be able to reproduce it yourself, because otherwise, how can you prove to your customers or yourself or your boss that this is fixed? So you'll want to be able to collect as much diagnostic data as possible. And I'll give some examples later on of what diagnostic data I think is very important to collect. But you can already think of some examples probably in your own applications. You know, what line of code did this originate on? Which customer was affected by this? Was this a paying customer or not? Maybe that's how you want to sort things and prioritize things. But having this diagnostic data allows you to do more, and it allows you to solve these problems. And the final principle is tend to these problems. So you've detected things, you've prioritized them, you have the diagnostic data to solve them. But as I said in one of the big sins, one of the big problems in production monitoring is no one's fixing these things, no one's looking at these things. So whose job is it to actually go and fix these errors? Somebody needs to care in your organization or in your team. So you need to make an organizational change or empower someone in your teams to actually own production quality. There's a bunch of different ways you can do this, and I'll go through a couple later on, because this is one of those things that's very personal to each team. You know, you might have if you have a big team, maybe you can split it out. If you have a small team, maybe you want to do a rota, but I'll go through those in a minute. So we've gone through sins, we've gone through principles, but let's make these a bit more actionable. So how can I implement these techniques in my company or in my product? So first off, you'll need to choose the right tools to solve these problems. I'm not going to say which tools you should use, but what I'll say is, here's a smart way to select and criteria for choosing ones based on the principles I've just gone through. So first thing, and I mentioned this earlier with you're going to miss things in log statements, or you've got black holes when it comes to log files. Most programming language, most web frameworks, most platforms will come with baked-in failure hooks. And if they're not easy to use, you can go and find a library, or you can go and find a guide of how to use them or how to implement these yourself. But actually, there's plenty of tools out there that use these failure hooks to capture production problems. So if you're looking for crashes in your app, most programming languages and platforms have exception hooks. So if you're writing a Ruby application, you can check the exit status of the application. If you're writing a Java application, there's actually a thread.uncaught exception handler hook that you can hook into. Almost every programming language, every framework has a way to detect the worst case scenario. And even if they don't have a built-in way, quite often you can make a failure hook yourself. For example, you want to look at performance problems. Pick what a performance problem means to you. Pick what that question is that we were talking about earlier. And say, right, any page load that is longer than 200 milliseconds, call this code, run this hook, and then that's where you're going to get your data for production problems. That's a metric for a production problem. We talked about this earlier, but pick a tool or build a tool that allows you to set impact of each problem. So you can't fix every bug. So heuristics to help you understand the impact of each problem, each bug or downtime incident or performance incident is essential. So we kind of mentioned a couple of these earlier. Things to look out for as a tool that will help you understand how many times each problem has happened, how many unique users were impacted by each problem. Is this getting better or worse? Is there a trend over time for this problem? This sounds very similar, but it's actually quite different. So assess severity. So you might have an error that's happening 1,000,000 times a day. And you're like, wow, this is really bad. What if it's a cron job? What if it's a background task? What if it's an admin page? That doesn't matter. It's irrelevant. Maybe you want to fix it if you have time. Great, go for it. But if you have a problem that's affecting a payments page, an onboarding flow, anything that's going to affect the actual interaction with your customer with the product, you might want to prioritize those. So find a tool or build a tool that allows you to segment and prioritize based on the severity of the problem. And that's a very personal thing. That will differ in every single company. So pick something that will allow you to get that data out. We just talked about diagnostics. Pick a tool that will capture diagnostic data for you. Or, even better, allow you to add in your own app diagnostic data. Like I said earlier, was this a paying customer that saw this problem? Or how many times did they load the app? Or how many dollars have they spent on my website or my e-commerce site or whatever you're building? So you want to be able to find these bugs, and then you want to be able to reproduce them. So I'll give you a kind of a case study scenario here. And this is true on mobile land, it's true on web land, but it's also true on the back end. There's some weird bugs out there. There are some really, really weird problems that you're not going to see yourself. So let's say your app is out in China, and they're using some phone that does not exist in the USA. And in your Android room, you've got 100 phones that are only bought in the USA. You're going to miss that. So how can you reproduce it? You need to know what device this happened on. Another good example, I'm not sure if anyone's seen this themselves. There's a really weird Unicode bug. I was expecting a groan there, because weird Unicode bug, I think, is a trigger word in a lot of engineering teams. So there's this really weird Unicode bug that happens in Ruby environments, where Ruby sometimes cannot tell the difference between Swedish encoding and UTF-8. And if you're building a company in America, you're building a software company in America, you're not going to have Swedish encoding enabled. You're not going to know what's going on there. So how the hell can you get that data to reproduce that bug? So capture it at crash time, capture it at error time, get that diagnostic data, get as much as possible. And there's a lot of tools out there that will do this for free automatically, that will give you encoding, country, device type, all this kind of stuff. But go one step further. Actually set interesting information that you've captured about your customer and about your application. Another good example there is, I talked to someone who was in a sales role recently, and they were doing a pilot program which was like a $500,000 deal for them. And the deal died because the sales engineer didn't realize that there was a problem for this one customer. So if you have a monitoring tool that says, hey, hang on, let's send diagnostic data that says that this is the name of the customer that's using the problem, then your sales engineer or whoever's responsible for looking at that can say, wow, that's a $500,000 deal. Let's look into that immediately. So there's some kind of areas that will help you choose a tool or build your own tool. Pretty essential. What about workflow? So I see workflow as the intersection between people and tools. So it's really important to detect these problems, but you want to actually fix them. You want to take a problem from being a known issue and a known bad issue after you've prioritized things into a solved issue. So what do we do there? So hopefully, your teams are already communicating using some kind of team chat system. HipChat, Slack, whatever you're using. If not, it's a really good idea. So why not surface production problems in these channels as well? This is where your team is. This is where your engineering team is. So having production issues come into a chat room allows you to start a conversation. So you can collaborate around these errors, these issues, these problems as they come in. So real scenario again. I've seen, we do it at Bugsnag. We have a fire hose of crashes coming in. We have group crashes coming in. And what ends up happening is we'll have an engineering chat room. And actually, I think we split to back end and front end now. But let's say in the engineering chat room, an exception comes in. And you're like, oh, crap, that was me. Does anyone know how to fix this? Or can anyone help me out with this? And you can also get smart with a concept of a history or a timeline. So if you're using a tool like Slack or HipChat, connecting your error monitoring to that, connecting everything else. So connecting deploys. So you can say, we just rolled out, this new deploy just hit production. And then, oh look, exceptions started coming in, or crashes started coming in. Make a history, make a timeline. You can then understand what caused things. So I mentioned a fire hose room. You can go pretty wild with this. You can have an engineering room where your aggregated errors come in. So you can say, this is a new error, and it's getting worse. And also, you could build a fire hose room. We have this at Bugsnag, where every single individual exception comes into this room. And it's kind of fun sometimes to see that, we have to solve, we're not really allowed to crash that much. But when we do have a problem, we can come into that room and be like, oh, wow, look, there's some stuff happening. We better fix that. So, and a good bit of evidence on this as well. From our data, the two most popular integrations with Bugsnag are Slack and HipChat, by far. Teams are already embracing this. Do it. I recommend it. Embrace collaboration. So in your workflow, you won't always be the best person to actually fix a problem. You're already pairing up when writing features and building new stuff, so why not pair up with solving a production problem? Select a monitoring tool or build one yourself that allows you to collaborate around these things. So, maybe you want to have an error come in that you've aggregated down, and you can comment around it and say, hey, does anyone know why this happened? Oh, actually, that's my fault. Oops, sorry. Who's this affecting? How about start a conversation, like I said with the chat services? Maybe you can @mention people. Maybe you can say, hey, Steve, you rolled this out, or hey, Jane, you did this. Help me out here. We've got some threads in Bugsnag with errors that have like 50, 100 comments in them. And they're kind of really interesting to read sometimes, of the story of how this started, how it got to resolution, and how people actually dealt with it. It's a great way to solve particularly tricky issues. So the other kind of part of workflow is make sure you track the progress of fixes. What is happening once this error has been detected? Who's working on it? Have you put it in Jira? Have you put it in whatever issue tracking service you're using? Have you assigned it to someone? Is someone checking in on this problem? If you are selecting a production monitoring tool or you're building one yourself, make sure it has something like this in it. Make sure it has a way to track the progress of a bug from inception to fix. Final part of the puzzle here in terms of how you can make changes in your organization. We've talked about how to pick a tool. We've talked about which workflow things are important. And I touched on this right at the beginning in the sins. What happens if nobody cares about problems? So let's solve that. So reassess your engineering team's structure a little bit. And that doesn't necessarily mean from the top down, CTO, VP level, whatever. Start small. Start in your team. Start in your kind of pod. Ask yourself the question, whose job is this to work on these problems? And this person or this team will be the advocate for your customer's experience in your app, which is a really important concept, I think. If you're focusing on shipping and getting things out, no one's advocating on behalf of the customer in production. So, there's a few ways to do this. I've jumped ahead one slide, 1 second. Technique number 1, and this is really super subjective. Work out what works in your teams here. But one thing that works really well is having a person or a team who is responsible for checking production monitoring tools and taking detected bugs to resolution. Making sure the most harmful bugs are being fixed, the most harmful production problems are being fixed. So I'll go through some of the pros and cons here. If you have a one person or one team, that's going to be great because they're going to be able to collect knowledge of common problems and common issues. There's going to be a clear path of responsibility, so nothing's going to get lost. Cons are, it's a little bit harder for individual engineers or individual software developers to learn from their mistakes. And also one con is that the bug team, the error team, must communicate everything back to the engineers that are writing bugs in the first place. Another option which works really well is create a rotation, create a rota in your engineering team. So on a weekly basis, daily basis, you can assign someone to look at production problems. Weekly works really well because you can't often solve those deep problems in a day. So pros and cons here. You know, the entire team on a rota gets to see the impact of production problems. And that step number one in my philosophies is care, give a shit, this is important. And this is a good way to get people to care. It also avoids a this is not my problem mentality. Everybody has skin in the game if you have a rota. The kind of big con with this is it can take a long time for the person who's on rotation to actually solve a problem because they're going to have to talk to other people in a team to say, what does this code even do? How does this work? But actually, I think that's a pro as well because that means you can get broader knowledge of your software throughout your team. This one is a very contentious one, but I'll tell you why it can be used to your advantage. So what if we could detect who was the last person to touch the code that caused the production problem? Now, this is not a blame game thing, but almost in every situation, the person who last touched that code is best placed to know what's happening in that area. And, you know, half the time, it was probably that person that caused the bug. But no need to do finger pointing. That person will be able to help you work out how to solve things. So big pros on that is that they know the code. And if this person actually caused the bug, they can probably immediately fix it. But obviously, big con, you don't want to create a finger-pointing culture in your software teams. So they're the kind of areas that are the three techniques, I think, that are worth thinking about to have ownership of production problems. So what do I want you guys to take home from this? So nobody left halfway through, so that's good. So first thing, avoid the big sins. And this is something just to think about, even if you don't implement anything, just catch yourself. Be like, are we doing that? Yeah, that's pretty bad. So don't pretend that nothing is wrong. Just don't do that. Don't wait for customers to complain about problems. Don't have a lack of visibility. And don't have a lack of ownership. Second take home, embrace these core principles. You know, we talked about accept, automate, aggregate, notify, prioritize, diagnose, tend. Try and remember all of these. If you want to take home just two of these, take home accept and tend. And everything else in the middle, you can fill in. And these are psychological kind of, just think about it, basically. Know that the problems will happen in production, and think about who's going to be fixing them. And then you can fill in the gaps in between, if you take home just two things. And the final thing, take action. Select or build your own production monitoring tools. Don't pretend that they don't exist. Put something in place. Get smart about your workflow, and make an organizational change. So, hopefully you guys found this helpful and interesting, and you've got something you can take back home to your engineering teams. Thank you for watching, and I'd like to open the floor up for questions as well. Any questions? Go ahead.
What's the biggest frustration that you've had with, in your opinion, in your experience, the biggest frustrations you've had within companies?
Absolutely. So the question is, what's the biggest frustration you've had in a company? So I think the biggest frustration is this signal to noise problem. So you're doing some work to detect problems, but you're just overwhelmed with data. There's nothing really you can do about it. That comes up over and over again when talking to our customers, and it's something that's worth working on as well. How can we group these together, clump these together, and not have just a stream of junk? I think that's probably number one. And the other frustration is the actionability of things. You know, can we take a problem that we know is a problem, but what do we do next? So they're the two big ones that I see all the time. I'm sure you see them in your organization as well. Great question. Any other questions? Go ahead. That's a great question. The question is the tend part of principles normally held down by the DevOps role? So this is a very personal opinion from me here, but I think the best people to understand and fix production problems in the performance and in the crashes side of production monitoring are the software engineers, because they're the people generally who are writing the broken code. In the availability and uptime side, absolutely in the DevOps role. But historically, I think the ops team or production engineering or the NOC or whoever would be responsible for all of these things. I actually think that's a bad pattern. And this is like a personal opinion for me. Because it means that you'll write code that's bad or slow or broken, and then it's like, see ya, it's not my problem. So that was one of those principles at the beginning of the sins almost. So DevOps definitely on availability, but on the other side of things, I actually personally think that the engineering team should be responsible for those. Cool. Go ahead. Oh yeah, I mean, that's why it's number one. So the question is, do people really not accept that there are production problems, and do they just ignore this? Is that fair? Yeah. No, that's fair. So are there mission critical kind of, or very expensive problems where accepting is actually a bad pattern? Yes, I think that's certainly true. If you're launching something into space and there's no iteration, way to iterate on things, then you're kind of screwed. You need to do everything before then. Actually, almost all situations now, that's not the case. I think that back in the day when you were compiling apps, and it would, like, when I worked in this finance company, it took 2 days to build this giant binary. 2 days. It was awful. So it was harder then. But now, SOA and splitting things out, everything is kind of siloed. That actual example I said earlier about that finance company, I think the level of acceptance is variable. Let's put it that way. I think you have to accept it a little bit, because otherwise you're assuming that you're so smart that you're never going to have any production problems. And I think that's important to always accept it. But how much work you do before production depends on, yeah, I guess how expensive or risky things are. Like this $1 billion crashes that we saw in this finance company, you don't want that to happen. That's going to really piss off your customers. But they still happen. So accepting it is still important. I think in areas where it's faster and easier to iterate, it's more and more important to accept and just be okay with it, because it allows you to ship code to production faster and only work on the problems that are known real problems. That's a good question, though. Any other questions? Go ahead.
On the leadership side, when you're dealing with the human factor that somebody knows that they created the bug, do you have any hacks for making them not feel bad about it and sort of going in a positive direction, like reducing the bugs, but also taking care of your staff?
That's a great question. So the question is, in the leadership side, if you know someone's responsible for a bug, are there any kind of tips or techniques for not making them feel bad that they introduced a problem? Is that right? So there's a couple of things that we do in our company, and I've seen other companies do as well. And mostly they're around learning. So normally bugs don't happen in isolation. You'll have, like the number one most common bug that we see in Bugsnag is uninitialized variables. So nil or null or whatever. And that's something where everybody has that problem, and it's something you can actually get better at. So you can come in and say, oh, I've got to protect these variables. I've got to solve this problem going forward. And what you can do is, if you have someone tending these things, you can almost build a checklist or a leaderboard of the common problems. You don't need to say who's causing these problems, but you can take the data of what the biggest, most common problems are, and then apply that in a learning exercise. So rather than playing the blame game, you can say, right, a lot of our problems are uninitialized variables. Here's how we're going to go ahead and write protective practices or code review or whatever in future to solve these kind of problems. So I think shifting the onus from this is my fault to these are common things where we can solve this again in future is a good way to solve that. Does that seem something you've worked in your teams? You seen that as well? Buy them a beer as well. Yeah, of course, that will. Any other questions? Cool. Oh, thanks everyone.